Hello everyone, hope you are doing well. Let's talk about heap. Heap is a brilliant data structure. It makes sure that we can access minimum or maximum element in a constant time. Let's see how it works. The heap data structure follows the concept of complete binary tree. In a complete binary tree, we always add elements from left to right. We can move to the next level only when the current level is filled. So see, this is how the complete binary tree looks like. Let's talk about MaxHeap. The MaxHeap property is the parent value must be greater than or equals to its children. In a max heap, the largest element is at root so that you can access max element in constant time. So these are the elements which are representing max heap. Let's see is it satisfying max heap property or not. Let's take up parent 9 which is greater than its children. Similarly parent 8 greater than its children. Similarly 7 and parent 6 which is greater than or equals to its children. So let's talk about the operations of MaxHeap. So obviously whenever you are adding an element, we add at last by following complete binary tree. So we are adding element 12. So now 12 is the children of element 5. Let's see is it satisfying MaxHeap property or not, which is not because 12 is greater than its parent. So that swap with the parent. Now the children 12 again greater than its parent 8, so that swap with the parent. Now again children 12 greater than its parent 9, so the swap with the parent. That's it. So we are done with adding elements into MaxHeap. If you closely see, we have total 8 plus elements. We figure out a solution in 3 steps. Log 8 base 2 which is equal to 3. So the time complexity is log n. When it comes to space complexity, you don't require any additional space. You can access the parent and children from the given element. So the space complexity is constant. So let's move on to remove. The max heap removes the maximum element from the heap. So obviously the max element is at root level. So what we do is first we replace the last element value with the root. So the last element is 5. We replace with root. Now we remove the last element. Now let's see is it satisfying max heap property or not. Now parent 5 which is less than its children, so that swap with the maximum children. So the max element is 9. So swap with the 9. Now again parent 5 less than its children. So swap with max element which is 8. So now we are done with deleting element. That's it. So obviously the time complexity is log n because on every iteration we eliminate n by 2 elements. Then the space complexity is constant, and this is pretty much clear. So the get max, right? So the maximum element always present at root so that you can access in constant time. We don't need any additional space. That's it. So let's talk about MinHeap. The MinHeap follows the concept. The MinHeap property is the parent value must be less than or equals to its children. In a MinHeap, the smallest element is at root so that you can access the minimum element in constant time. So these are the elements which are representing MinHeap. Let's see is it satisfying MinHeap property or not. So we have parent 1 which is less than its children. Similarly parent 2 less than its children. Parent 3 which is less than or equals to its children. Similarly parent 5 less than its children. So let's talk about the operations of MinHeap. So we are adding element 0. So let's see now children 0 is satisfying MinHeap property or not. Let's validate. Now the current element 0 which is less than its parent, so that we just need to swap with the parent 4. That's it. Now again children 0 less than its parent 2, swap with the parent. Now again children 0 less than its parent 1, so the swap with the parent. That's it. So we are done with adding elements into MinHeap. The time complexity is obviously log n and space complexity is constant. Let's talk about removing an element. So the min heap removes the minimum element from the heap. Obviously the min element is at root, so that we replace the last element 4 with the root, then remove the last element. Now let's see, is it satisfying MinHeap property or not. Now parent 4, which is greater than its children, swap with the lowest value, which is 1. Now parent 4 greater than its one of the children 2, so swap with the children 2. That's it. So we are done with removing element from MinHeap. So obviously the time complexity is log n, space complexity is constant. When it comes to getting the minimum element, obviously it presents a truth, so time and space complexity becomes constant. That's it. Hope you like the explanation. Please subscribe and share. My name is Shrinu. I thank you so much.